Dream 11 is India's biggest fantasy sport platform. This platform has over 150 million users who create teams, join contests, and more. This massive user base generates billions of events and terabytes of data daily. Handling this much amount of data is very critical for businesses to provide good user experience. Cricket is very big thing in India. Since 2008, IPL has fueled cricket fever in India. It is a festival in India where millions of people celebrate it. But now it is not just about watching games. Cricket fans engage with the game more than ever, be it as a spectator at stadium, purchasing merchandise, or engaging on a fantasy sport platform. Think about the scale for a second. Millions of people at every second engaging on this platform, creating teams, joining contests, and competing with each other. All of these things are happening within seconds. So how Dream 11 achieved all of this? In this video, we will deep dive on how Dream 11 built its data platform to serve millions of users. Like any other startup, Dream 11 started with very basic design philosophy from going 0 to 1 first. It starts with listing down all of the requirements and checking boxes. Always remember, when you go from 0 to 1, the functional delivery of the system is very important. The system should work first, then you can think about how to improve and optimize different things as you go forward. So Dream 11 is a sport fantasy platform where users register themselves, play the role of team selector to create their fantasy sport team, and join the fantasy sport contest. Heavy user transaction are nature of their business. So here's the first architecture diagram that they developed. Very basic architecture. As you can see, the backend services are powered by AWS Aurora database. This database is AWS's own relational database. The Dream 11 app is connected to database server. Whatever users do on their app, all of these information will get stored inside Aurora database. This is called as OLTP system, online transactional processing. These systems are mainly designed for transactional related workload. So whenever you want to insert, update, delete any data, OLTP systems are used on the first place. But if you want to understand last 5 years of data and understand trends and performances, then you cannot use OLTP system. For that, we will use something else. This is the first challenge that they solved. They built the basic data pipeline where all of the data coming from the application to RDBMS, they stored it on S3, simple storage service provided by AWS. S3 is an object storage where you can store any types of file you want, such as audio, video, CSV, Parquet, whatever you want to store, you can easily store it. So what they really did is that they extracted data from the RDBMS and stored all of those data onto S3 for further processing. To extract the data from RDBMS in real-time manner, they used Apache Kafka, which is generally used for processing real-time data. So whenever new data comes inside the database, it will automatically get captured by Apache Kafka service. The data will get stored at landing zone on S3 buckets, and the data will be loaded on data warehouse solution provided by AWS called as Redshift. It is an OLAP-based system, online analytical processing, used for mainly analytical type workloads. So any data scientist or data analyst wants to understand about data, run SQL queries, they can easily do that onto Amazon Redshift. This pipeline is mainly about the application side of data, but we also need to understand the behavior of users, such as on which page user spends more time, the journey of user from opening app to building a team. All of these events come from third-party tools such as Google Analytics. So we also need to integrate all of these data in our system. Now here's the pros and cons about this system. Looking at the pros, the tech stack that they use was easy to build. Most of the heavy lifting is done by third-party tools. Maintenance is very low as there are few data pipelines. Pretty good for any startup that is going from 0 to 1. Here are some of the cons. If you look at the transactional and behavioral data, they are not together. They are both disconnected. So if you want to do the joint analytics, you won't be able to do it. Third-party data is not in our control. We need to use whatever the data that they provide and make use of it. So sometimes if you want to get the specific record and understand the user behavior, we won't be able to do that because these tools do not capture them. When the data started growing, they were having the latency issue, and they decided to build the version 2 of this system. Now here are the goals of second system. Data platform as a service. That means anyone in Dream 11 should be able to push or consume data without data engineers involvement. The platform should be able to handle high volume of data consisting of billions of events and terabytes of data. It should handle both batch and real-time data. With all of this, the data availability at individual needs based on transaction, payments, and supporting events should be provided for the analytics. It should give raw access to data without any performance impact. Now in version 2, the first thing that they built was data acquisition service to accept the data from Dream 11 app, website, and the third-party vendor. So it gets easier to add new data sources in the system. To process high volume of data such as batch and real-time streaming, they started using Spark and Flink. With that, they also wanted to give the raw access to data so that users can directly run query on top of files and start generating insights. For that, they use AWS-based Glue Catalog Athena table so that you can directly query on top of raw files and start running SQL query to analyze data. And as per the previous architecture, they have the ETL system placed before storing the data onto Amazon Redshift for better analytics. At this point, they were serving all of the kind of requirements from processing batch data, real-time data, having the data warehouse in place, and making sure all of the system work properly. Now, if you want to learn how to build projects like this and get hands-on experience, then I have something for you. The sponsor of today's video, ProjectPro. ProjectPro has some of the amazing projects available in the space of data engineering and big data. Now, here are the two projects that I would like to recommend from the ProjectPro that are really important if you want to learn how to build data system like Dream11. The first project is Build Analytical Platform for E-commerce using AWS services. This project will give you understanding about Apache Flink, AWS Kinesis, S3, Lambda, CloudWatch, DynamoDB, and many more. The second project I would like to recommend is PySpark project. Build a data pipeline using Kafka and Redshift. By doing this project, you will get understanding of all of the services used by Dream11 and how they build the entire data architecture. With this, they have more than 250 projects available on their website, and all of these projects are created by top industry experts from Microsoft, Google, Apple, and all over the world. So if you want to learn how to build all of these projects by yourself and get hands-on experience by building them, then I will highly recommend you to go to projectpro.io and get the subscription. And if you use the link that I've provided below, then you will get an exclusive discount on the subscription. So what are you waiting for? Visit projectpro.io to learn more about it, and let's continue with our video. They were able to implement everything, but now they wanted to add more flexibility. What if each requirement is self-serve? What it really means is that at the consumer side, we have many different users such as business users, data analysts, machine learning engineers, data scientists. All of these people want the specific kind of data based on the requirement. So instead of being dependent on data engineers to provide the right data based on the requirement, what if these users can directly build data pipeline without needing the help of data engineers? This was the goal of version 3 architecture of Dream11. Here is the current architecture. As you can see in the architecture, they built Data Highway, Data Beam. These are their internal tools or services built completely based on their requirement. Data Highway accepts any data sent over HTTP. So if any third-party vendor want to send any data, they just have to hit the API and it is done. Data Beam is self-serve tool for setting up data pipeline between MySQL and Redshift without worrying about the underlying technology. At the middle, you see the Streamverse, where you can build the real-time data pipeline just by dragging and dropping different operators such as filters, join queries, etc. All of these are web-based tools that they build internally based on the requirement so that the users don't have to worry about the underlying technology. All they need to do is click few buttons and get the work done. You don't need knowledge of Spark, Flink, or anything else. All you need to know is basics of SQL, and you can create your own data pipeline. They build all of these things by themselves. Streamverse is for real-time data streaming. DataStitch is for batch ETL. They also have real-time alerting and monitoring system called as the DataQuick. Just like this, they build the many individual data platforms to serve different use cases. Now, what can we learn from the journey of Dream11 from going from 0 to 1 and then building this amazing architecture to process billions of events every second? Always start simple. You don't need to build a complex architecture diagram at the first phase. First, work on the functional requirement, what business really want, and then you can start finding gaps and improving system as you go forward. You can start with a serverless architecture and understand the patterns your platform is having, and based on that, you can improve the system and build a solid data architecture. All of these systems are definitely going to fail at some point, so make sure you put the mechanism to monitor all of these things. I visited AWS Cloud Summit Mumbai a few weeks back, and I learned all of these things from there. I wanted to share my experience to you guys so that you guys can also learn from me. If you want me to create a similar type of content, then let me know in the comments. Then I will make more case studies on different companies and we can understand the architecture diagram behind that. So let me know in the comments if you like this type of content, and I will make more of it. This was all from me. Don't forget to hit the like button, and if you are new here, then don't forget to hit the subscribe button. Thank you for watching. I'll see you in the next video.